Hello everyone, this is Cameron from EDUCO, and in this video we're going to be looking at absolute value expressions. So to look at some learning goals for this video, we're first going to define what an absolute value is, and then we're going to look at a couple of examples of evaluating absolute value expressions. So here's a little summary chart or sheet to define what an absolute value is. So first of all, absolute values can be thought of as the distance on a number line away from zero, okay, or the origin. Or we can simply think of it as removing any negative sign in front of a number. Because when we're looking at distances, we're not worried about any negative signs, okay? We don't include any negative signs when we're talking about distances. Distances are always positive. So absolute values are really distances. So whenever we take the absolute value of a number, it will always be positive, okay? Because it's always the distance away from the origin or zero. Now, the absolute value formula, okay, the base formula for the absolute value is given below here. That says that the absolute value of x, okay, now you notice that surrounded by the x, there's these bars, okay, and we want to pay close attention to these bars. These bars means that you're taking the absolute value of whatever number is inside, okay? So these bars represent absolute values. So pay close attention to that. So the absolute value of x, okay, x here just represents any number, is equal to x, so whatever number that's inside of those bars, if x is 0 or greater than 0. So if it's positive or 0. But if x is less than 0, so if the number inside of the bars is negative, then we must add an additional negative sign to ensure that when we take the absolute value, everything remains positive. Okay? So let's look at a couple of examples of evaluating absolute value expressions. So in question 1, we want to evaluate the absolute value of 3 minus 5, subtract the absolute value of 8 minus 12, minus 6, divided by the absolute value of 12 minus 8, minus 16. So let's start off with the absolute value of 3 minus 5. So 3 minus 5 is negative 2, so that's going to be the absolute value of minus 2. Subtract the absolute value of 8 minus 12, which is the absolute value of minus 4. Subtract 6. Divided by the absolute value of 12 minus 8, so that's the absolute value of 4, minus 16. So now, on the top, we have the absolute value of minus 2. So remember, those bars represent, those bars tell us that we're taking the absolute value of negative 2. So when we take the absolute value, the number becomes positive. So instead of minus 2, it's just going to be plus 2. So the absolute value of negative 2 is just plus 2. Subtract the absolute value of minus 4. Likewise, it's just going to become plus 4. And then subtract 6 divided by the absolute value of 4. Now, since this number is already positive, we're going to keep it the same. So it's still plus 4 minus 16. So this equals 2 subtract 4, which is equal to a minus 2, minus 6, that's equal to a minus 8, divided by 4 minus 16, so that's going to be equal to a minus 12. Now notice these two negative signs will cancel on top and bottom, and if I divide both top and bottom of the fraction by 4, I'll get the most reduced form, which is 2 over 3. So that's the final answer in this case, okay, in this question. So now let's take a look at question number 2. That asks us to evaluate the absolute value of x minus 16, subtract 2, divided by the absolute value of 19 minus x plus 1, if x is greater than 20. So here's something that's unique to this question that wasn't in the previous one. And that's because we've introduced a variable now. So notice that there was no variable in the last question. But in this question, we have the absolute value of x minus 16 and the absolute value of 19 minus x. So in order to evaluate those type of expressions, we must be given some constraint on the variable, because that constraint will change the answer, okay? So if you don't pay close attention to this constraint, you may get the wrong answer. So let's start off by looking at the absolute value of x minus 16. Now, in order to take the absolute value, we need to know whether or not whatever's inside of those bars is positive or negative. So if x is greater than 20, then I know that any number that's greater than 20 minus 16 is going to be a positive number, right? So I know that the absolute value, I know that x minus 16, whatever that number is, it's positive. So it's going to stay the same when I take the absolute value. So it's going to still be x minus 16. Subtract 2. And then that's divided by, now the absolute value of 19 minus x. Okay, now let's take a close look at this one. If x is greater than 20, then I'm taking a bigger number away from 19. So that means whatever this number is inside of the absolute value sign, this is negative. Now, if a number inside of an absolute value sign is negative, then that means we have to add an additional negative to account, to ensure that everything's positive once we take the absolute value. So instead of 19 minus x, that's going to be a negative outside of 19 minus x. And that's because the number inside is negative. And then I'm going to add 1 to this. So then on top, I have x minus 16 minus 2. So that's x minus 18 divided by. Now, I'm going to distribute this minus sign into both terms inside of this bracket. So that will give me negative 19 plus x plus 1. So on the top, I can't really simplify any further. But on the bottom, I have positive x, but then negative 19 plus 1. That's also going to give me negative 18. And now notice that the same term on top is what's on bottom. So these two terms will cancel. And my final answer in this question is equal to 1. So going back and reviewing what we've learned, we've defined an absolute value. We know that we can look at an absolute value as the distance on a number line away from the origin or from 0, okay? Or we can simply think about it as removing a negative sign from a number, okay? Because distances are always positive, so we never explain a distance to someone using negative numbers, right? It just doesn't have any physical meaning. So we take that negative sign away. And then we looked at a couple of examples of evaluating absolute value expressions.